Hello, I'm Colin Primrose and I'm a radiology registrar based in Glasgow, Scotland, and this is a showcase presentation which is a refresher on K-space and time-resolved MRA. So we'll start with K-space. K-space is a grid of raw data, which is a visual representation of the echo signal, and this is converted into the final MR image using a Fourier transform. It can be difficult to understand K-space, but the two important principles to grasp at the moment are that the center of the K-space contains information regarding contrast, while the periphery contains information pertaining to edge definition. And also, that every point in K-space contributes to that final image. So with this first point, when this is applied to an angiogram, if we just have the center of K-space, we have contrast in our image, but not much edge definition. But if we just have the periphery and not the center, then we have edge definition, but not much contrast. So we try to time our acquisition, our filling of K-space, when there is peak contrast in the vascular bed. Acquiring less K-space takes less time, so we can image much faster if we're selective. And looking at these images, you might ask, why don't we only image the center of K-space? And that brings us on to point 2. Every point in K-space contributes to that final image. We can see if we have a single artifact at one point in the K-space, changes our final image, depending on where it occurs. So as we've mentioned, it's important to acquire the center of the K-space when there's peak contrast within the vascular bed. But we can choose to fill K-space at different times during the sequence. In theory, these images could be obtained at the same sequence starting at the same time, simply by choosing to fill the center of K-space at either the beginning, middle, or end of the acquisition. In practice, the best method is usually to commence the sequence as close to the contrast peak as possible and immediately fill the center of K-space. Now we'll move on to talk about K-space ordering. There are various ways that K-space can be filled, and which method slightly depends on the application. So in MRI, orthodox way of filling K-space is linear Cartesian sampling. And that's where the lines are filled row by row from top to bottom. But this isn't ideal in angiography, where we're trying to fill the center of K-space early on. So elliptic centric sampling is a method that fills the center of region, but not whole lines at a time. And this means high contrast center region can be filled earlier in the acquisition, and we're less likely to mistime that contrast bolus. So contrast enhanced MRA can be seen as slow compared to CT angiography, but the lack of ionizing radiation means we can run the sequence again and again. And this can give us dynamic information. In this lower limb angiography, we see pure arterial imaging without the distraction of venous overlay. So time-resolved MRA, it's a spoiled gradient echo sequence that uses multiple acceleration techniques, including view sharing. Now, view sharing involves filling that center of K-space over a short period of time and underfilling the rest. The missing data from the periphery of K-space can be filled at different time points at either side to gather enough data to reconstruct a full image. So an example of this is where the center of K-space is filled fully in each acquisition and the periphery of K-space is partially filled at each acquisition, and these are added together before reconstructing a full volume. Different vendors choose different ways on how to perform view sharing in order to create their own time-resolved package, each with their own name. I'll run through a couple of examples. So this is a linear keyhole sampling method. It's a classic method in time-resolved MRA, and it uses a rectangular K-space grid. The center lines are sampled multiple times following the administration of contrast, and the peripheral lines are sampled periodically. Another example of a keyhole sampling method is 3D tricks. A K-space is divided into 4 concentric regions which are sampled sequentially. So some take-home points. The center of K-space gives us contrast and the periphery gives us the details. We don't need to acquire them at the same time. And in contrast enhanced MRA, there's numerous ways to fill K-space, and a basic working knowledge of this is important to ensure optimal contrast. I'd like to acknowledge Christopher Francois, Jeff Maki, Charles Dumoulin, Elizabeth Hecht, Charles Roditi, Kevin DeMarco, and Peter Douglas. Thanks.